This is going to be today's review. So I want to point out one thing, that when you're doing these problems, make sure that you pause, think about the next step, what the answer is for the next step, and then write out what you think the answer is, hit play, and then see if you're correct. In other words, you don't want to just hit play and just copy all the steps that are happening in this video, because you're not going to learn that way. The best way to see if you're actually understanding it is by trying the next step and then hitting play in this video to see if you did it correctly. So think about it before you watch the next step. So for this equation, you should have negative 2y plus 6 equals negative 4y plus 4. So that's the first step right here. And the reason will be given. All right, step 2, you can see here that what's different between the first and the second step is that they added 4 y's to both sides. So what I did first is I copied the original equation, because you can see here we still have negative 2y plus 6 and negative 4y plus 4, which is what I wrote here. We're just going to show that we're adding 4y to both sides now. So I'm going to put plus 4y plus 4y. And what I'm doing here is I'm adding 4y to both sides, so it lets me know that this is the addition property of equality. In the next step, you can see here they simplified. So we combine the 4y with the 2y, so we have 0 pairs here, so those are gone. And then we have 4 y's and 4 negative y's, so when you combine all this, those are all canceled out. So we're left with 2y plus 6 equals 4. So that's my next part here. And notice, algebraically, you can see when we do 4 minus 2, that's 2. And when we combine 4 positives and 4 negatives, when we add opposites, they cancel each other out, and you can see we're left with just 4. And again, the reason was simplify. Now, from this step to the next step, I can see what changes is that we still have the 2y plus 6 here, except now we have 6 negatives over here. I still have the 4 positives, but we also have 6 negatives there. So I copied the original 2y plus 6. You can see we have 2y plus 6. We have 4. We still have 4. So I copied the original equation from before. 2y plus 6 equals 4. Except now we're taking away 6 on both sides. So I'm going to take away 6 here and take away 6 here. And notice that they took away 6. They put them right next to the 6 ones because these are like terms. So when I subtract 6, I put it next to this one so I can see that I'm going to combine these two together because these are like terms. And same thing on this side. Since I took away 6 on both sides, I know this is the subtraction property of equality. And then in my next step, you can see here, when we combine 6 negatives, 6 positives, they all cancel out. 6 negatives combined with 4 positives, we're left with 2 negatives. So now we have 2y equals negative 2, which is what I end up getting after I simplify. And algebraically, you can see 6 positives, 6 negatives. When you combine it, that's gone. 4 positives and 6 negatives, we're going to be left over with 2 negatives. Then from this step to the next step, you can see here, we still have 2 y's, we still have 2 negatives, except that they split it up into groups. So these were split up, and when we split them up, we end up doing what we call the division property of equality. So the way I show this algebraically is I'm going to divide this side into 2 groups, divide this side into 2 groups. Notice we're not dividing by 2y, because all we're showing is that we're dividing it into 2 groups. So that's what the division of the 2 lets me know, splitting it up into 2 groups. And again, this is division property of equality. And by doing division property of equality, we can see that each y matches up with a negative 1. So that lets me know my solution is y equals negative 1. And you can see here algebraically, 2 divided by 2 is just 1y, and negative 2 divided by 2 is negative 1. And the reason, solution. And in this example, you can see here we have 3 negative y's over 4, so 3 of these. So I write it out like this, 3y over 4, because we have 3 of them, and they're negative. So I put negative 3y over 4. And one thing I want to point out is that when you have y's and 4's, they might be mixed up. You might think that this is a 4. So what I recommend is making it like into a curly y, so it makes it more obvious that that's the variable y and not the number 4. Because you can see that this 4 looks kind of like a y. So by making it a little bit more curly, you can see that it stands out better as a variable y. So we have 3y over 4, negative 3y over 4, minus 6, which is what I have here. And on the right side, I have 4 of them, so negative 4y over 4, which is what I wrote here. And then 3 negatives, so minus 3, and the reason would be given. Now I can see from my next step, what changes is that they added 4y over 4 on both sides. So we added 4y over 4 on both sides. And notice that the rest, everything else is identical. So what I did is I copied the original equation that I started with, except now we're going to be adding 4y over 4 to both sides. So plus 4y over 4 to both sides. Since I'm adding 4y over 4 to both sides, that's the addition property of equality. And then your next step you can see is going to be just simplifying. So when you combine this, we're going to be left with 1y over 4 when we combine these 4 positives with the 4 negatives, they all cancel out, and we're left with just 3 negatives. And algebraically, you can see here, right, 4 positives, 3 negatives are going to be left with 1. Bring down my negative 6. 4 positives and 4 negatives are going to cancel each other out, and that's why we're left with just 3 negatives. And this is, again, simplifying. Now, from this step to the next step, what's different is I can see that they introduced 6 positives here and 6 positives here. But everything else, you can see, is identical. So that's why I copied the previous equation. But I know that I'm adding 6 to both sides, so that's what I'm going to show now. And notice that they added the 6 with these. They put the like terms together. So I'm going to put the plus 6 underneath this here, plus 6 over here. And again, by adding 6 to both sides, this is called addition property of equality. And now in the next step, we're just going to simplify. So this 6 positives combined with 6 negatives are all canceled out. 6 positives combined with 3 negatives, we're going to be left over with 3 positives. So we're left with just y over 4 equals 3. And again, you can see here algebraically, this is what I have in the next step. Because when you cancel these cancel each other out, combine this, you're just going to get positive 3. And again, this is called simplifying. Now from this step to the next step, you can see here, we started with 1 copy of this. Now we have 4 copies. We had 1 copy of 3, and now we have 1, 2, 3, 4 copies of it. That means that we multiplied both sides by 4 because we have multiples of this and we have 4 multiples of that. And the way we show that work, again, we're trying to demonstrate multiplication property of equality. Therefore, what you want to do is you want to show we're multiplying both sides by the same amount. In this case, we're multiplying both sides by 4. So, because one of the mistakes that I saw yesterday was that instead of putting 4 times 3, I saw the answer of 12. But again, to demonstrate this property, we want to show what are we multiplying both sides by. So in this case, again, it's 4 times 3. We multiply both sides by 4. And then in the last step, you can see 4 of these together make up one whole amount. Therefore, 4 times that amount is just 1y equals, and then we have 12 on the right side. That's our solution. And here's our last example. We have 3x minus 2 equals 7x plus 6. So that's our algebraic step here. And the reason will be given. And then when I compare this step to the next step, I can see that what's new is they took away 3x on both sides. So as stated before, we copied the original problem. And now we're just going to show we're taking away 3x to both sides. And notice that they grouped the x's together. So I'm going to take away 3x here and take away 3x here because those are my like terms. Subtracting 3x to both sides means we're using the subtraction property of equality. So make sure if you're using the property of equality, you're always showing the identical step on both sides. Now, in my next step, you can see here, when you combine 3 negative x's with 3 positives, we're just going to be left with 4 x's. And when I combine these 3 with these 3, they cancel all out, and we're left with just 2 negatives. So you can see here, adding opposites, they're gone. 7 minus 3, 4x. And then this is called simplifying. Now, this step to the next step, I can see here, what's different is we have 6 negatives here. Originally, we had 2 here. Now we have a total of 8, so we also added 6 negatives on both sides. In other words, we're taking away 6 here, we're taking away 6 here. Notice everything else is identical. This is why we copied the previous step. And now, this is called subtraction property because I'm taking away 6 on both sides. So to show the subtraction property of equality, take away 6 on this side, take away 6 on this side. Notice I put the minus 6 under this one because these are my like terms here. I'm not going to combine it with the x's, I'm combining it with the 1's. So I line it up here to simplify and organize my work. And now my next step, we're just going to simplify. 6 negatives combined with 6 positives cancel each other out. So you can see here, 6 positives and 6 negatives, they're gone. They cancel each other out. And then 2 negatives and 6 negatives, there are no 0 pairs. So we just end up with 8 negatives altogether. So 2 negatives and 6 negatives is just 8 negatives altogether. So this right here is called simplifying when we combine our like terms. And then you can see from this step to the next step, we had 8 negatives here. We still have 8 negatives here. We have 4 x's here. We still have 4 x's. So that's why I copied the equation again. The only difference is that they split this up into 4 equal groups, and they split that up into 4 equal groups. When you split them up into equal groups, what you're doing is called the division property of equality. And the way we show division property of equality algebraically is count how many groups you created. We have 4 groups here, 4 groups here. That means I'm dividing both sides into 4 groups. So we split this up into 4 groups, split that up into 4 groups, division property of equality. And by doing that, it allows you to see that every x matches up with 2 negatives, which in other words means that our solution would be x is equal to -2. So I'll put -2 equals x, and that would be my solution.